Here's a mock scenario for a project architecture explanation. Let's assume you worked on an e-commerce application. Use this template to practice your explanation. Scenario: e-commerce application for a retail company. 1. Project overview. Our project was to build an e-commerce platform for a retail company to manage their online store. The key features included user authentication, product browsing, order management, payment processing, and real-time notifications. The platform serves two main user groups: customers and admins. 2. Architectural style. We used a microservices architecture to ensure scalability and independent deployment of services. Each core functionality, like user management, product catalog, and payment processing, was developed as an independent service. These services communicated with each other via REST APIs and asynchronous messaging using Kafka. 3. Technology stack. Back-end, Java with Spring Boot for microservices. Front-end, React.js for a responsive user interface. Database, MySQL for relational data. Examples: user profiles, orders, and Redis for caching frequently accessed data like product details. Messaging, Kafka for event-driven communication, such as sending order confirmation emails. Authentication, Spring Security with JWT for user authentication and role-based access control. 4. Key components and flow. The system was divided into the following services. User service handles user authentication and profile management. Product service manages the product catalog, including categories, pricing, and stock. Order service manages cart operations, order placements, and tracking. Payment service integrates with external payment gateways like PayPal and Stripe. Notification service sends email and SMS notifications for events like order confirmations. For instance, when a user places an order, the order service triggers an event in Kafka, which is consumed by the payment service to process the payment. Once the payment is confirmed, the notification service sends a confirmation email. 5. Deployment and scalability. The application was containerized using Docker and deployed on Kubernetes. We used auto-scaling policies to handle increased traffic during peak times like Black Friday sales. Services were monitored using Prometheus and Grafana for performance metrics and alerts. 6. Challenges and solutions. One of the challenges we faced was ensuring database consistency across microservices. We implemented the Saga pattern to maintain consistency during distributed transactions. For example, if an order was created but the payment failed, the system would automatically roll back the order creation. 7. Results. The platform successfully handled over 50,000 concurrent users during peak sales without downtime. Average page load time was reduced to 1.5 seconds, and customer satisfaction increased by 25%. The modular architecture also reduced deployment time for new features by 40%. Practice questions. Why did you choose microservices over a monolithic architecture? How did you ensure secure communication between services? Can you explain how the caching mechanism improved performance? How would you handle a payment gateway outage? This structure should help you confidently explain your project architecture in an interview. Don't forget to like, subscribe, and hit the bell icon to stay updated on more interview tips and software development content.